Hello, so let's now talk about some practical applications of the Boolean functions we talked about earlier. So specifically, we will talk about designing adders, and we'll see half adder and full adder, and we see the motivation behind it. So let's say we want to add two binary numbers. One is x, which is like let's say 0, 1, 0, 1, 0, and one is y, which is 1, 0, 1, 1, 1. Okay, so how do we add it? So we add 0 and 1. 0 and 1 is 1. Then 1 and 1 is 2, which is 1, 0. But we have to do 0 here and carry here. And then 1 plus 0 plus 1 is what? 0. And then carry is again 1. Then 1 plus 1 plus 0 is 0. The carry is 1. Then 1 plus 0 plus 1 is 0 and carry is 1. So my answer is this. Okay. So now note that typically we want to add two bits. We want to add two bits, and sometimes we have a carry and sometimes we do not have a carry. But for the first fit, so for the least significant bit, so for, we say here, least significant bit, no carry is there. Correct? Because the first thing we start with. Okay, for all others we might have a carry. Okay, so this means that we need an adder in which we can have two main inputs and one carry input. Okay, so then a full adder has inputs x, y, and carry in, and output sum and carry out, while a half adder is designed for the first least significant bit, which has only x and y as input, and output is sum and carry out. Okay, now it just is a matter of making a table of inputs and outputs and designing functions, which we have done already. So let's do that. Let's start with half adder. Okay, so half adder, we have input x, input y, two inputs, right? So we have 0, 0, 0, 1, 1, 0, 1, 1, and we have output sum and output carry out. So sum 0, 0 is 0, 0, 1 is 1, 1, 0 is 1, and 1, 1 is 0, and this is 0, 0, 0, 1. Okay, because if we have 1, 1 input, then we have sum of 0 and carry is 1. So now sum is what? So first of all, let's write carry out. So carry out is just our sum of products form is just x plus y, x times y, and our sum. So sum I can write it like this. So I can just write xy bar plus x bar y. Can do that, right? Combining these two terms. But if I do it using a product of sum expansion, you will see that uh, it will be a little bit easier. So we have here x bar plus y bar, and then x plus y. Okay, so this is x plus y. Okay, now this x bar plus y bar, I can write it as xy bar and x plus y. Okay, now let's say we have to design it using actual circuitry here. So then we will say our input is x. So input line x like this, input line not like this, input line y like this, and input line not like this. Okay, So now what is C out? C out is X and Y. So C out, this is equal to X, Y. Okay. And what is sum? Sum is XY complement. So I have to take the knot of this guy and AND it with the OR of this and this. So I will do this. All of this and this and this I have to. So this is my sum. And note that this is not the only representation. If we use product of sum form, we will get an exclusive OR gate, which is usually available, and this is an easier implementation. But I'm trying to avoid exclusive OR because we have not talked about it. So now, since we have these boxes, now this is the convention that not box is represented by this sign, and box is represented by this sign. Now this can be multiple inputs here, and OR box is represented by this sign. Okay. Okay. So now let's talk about the full adder now. Okay. So full adder. Okay. So full adder, we have three inputs, X, Y, and Cin. So we'll say X, Y, and Cin. So then we have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1. Correct? And then we will have sum. So if we have 0, 0, 0, we have 0, then we have 1, then we have 1, then we have 0, then we have 1, then we have 0, then we have 0, then we have 1. And then we have carry out. This is 0, this is 0, this is 0, this is 1, this is 0, this is 1, this is 1, this is 1. Okay. This is again, just a routine exercise now. So nothing special here. Once we make a table like this, it's just a matter of just writing it. Okay, so then we have sum. Now what can I write? I can write sum is equal to, let's write it in product of sum forms. So this is X bar, Y bar, Cin plus X bar, Y, Cin bar plus this one X, Y bar, Cin bar plus, and then we have X, Y, Cin. Okay, so then this C out, this is equal to X bar, Y, Cin plus X, Y bar, Cin plus X, Y, Cin bar plus X, Y, Cin. Okay. Okay. Now we can again design a circuit. We can have, okay, let's see. Let's use more space here. Now we have input line X, input line Y, and input line Cin. So X, Y, and Cin. Okay. Now this is the input line X bar. This is the input line Y bar. This is the input line Cin bar. Now this is very routine kind of thing. So we have X bar, Y bar, and Cin. So X bar, Y bar, and Cin. This is going to be ANDed. So then this is like this, right? And X bar, Y, Cin bar. So X bar, Y, and C in bar. So, right, and then X, Y bar, C in bar. So X, Y bar, and C in bar. So C in bar was here, so I can take it from here, right? Okay. So X, Y, C in. So then this guy, so this is bad drawing, and this is, so then this guy I will OR them all to get my sum. Okay. Now this kind of circuit, you can definitely draw it more neatly, but the point is that we have to AND them, and then we have to OR the final outputs of AND. And here we have assumed that our AND box or AND gate can take more than two inputs. Okay, otherwise you have to use two AND gates if it is restricted to using only two inputs. Okay, now this is a circuit for sum, and similar is the concept for carry out here. Now if you have to add, for example, if you have to add 3-bit numbers, so uh, you have x0, x1, x2, y0, y1, y2, where this is the least significant bit. So what we will do, we will put x2 and y2 to half adder. Okay, this will output a sum and a carry, right? So then this sum is my output of maybe 3. Okay, and this carry will go to the full adder, and x1 and x2, so this is C out. So x1 and y1 will go here. So there, here also we will have a sum which will be our output and our carry out, and this carry out will go to another full adder, and then x2 and y2 will be there. Okay, and then this sum is our O1, and carry out is our O0. Okay, okay, so this is how we will use half adder and full adder um, in summing two binary numbers, some bits. Okay, and keep on adding half adder and full adder. So this was there was nothing special here. We just used our skills which we developed to find sum of product and product of some expressions to actually go to some applications of making those circuits, and how we can use uh, those uh, those expressions in finding something which is meaningful. So this is it about the half adder and full adder. Hope it was easy to understand. Thanks for watching. Hope you liked the video.